We start by entering our data, and I suggest that if the calculator you're not using is not your own, that is to say it belongs to the school or you borrowed it from a friend, I would reset it just to make sure all the settings are where they should be, and the likelihood of encountering problems is a little bit less. To reset this calculator, the easiest series of steps is to just press second, and then I'm going to plus, which is memory, and then just enter 712. So again, second plus 712. It'll reset all the RAM. It's all cleared, and I think my version is a little different than the version you're using, but for the most part, all the steps are going to be identical here. So now that our RAM is cleared, our calculator is reset, we're going to go ahead and enter our data. So to do that, I press Stat, and then option number 1 is to edit data. And you can see I have list 1 and list 2 available. So in order to enter the data, all of my X's are going to be in list 1, and the corresponding Y values will be stored in list 2. So starting up here at list 1, I'm going to go ahead and enter the 144, followed by the 132, the 120, the 108, 96, 84, 72, and then finally 60. So you can see I have exactly 1, 2, 3, 4, 5, 6, 7, 8 values. I'm on the 9th row and it's blank still. Now I'm going to go over to list 2, and from here I'm going to enter the corresponding Y values. And this is from the example that we did earlier on with the distance from the wall and the field of view. We collected this data in class. So I'll enter 20.7, 19.6, 17.3, 16.2, 14.8, 13.1, 11.4, and my final value is 9.3. Now it's important to note that I have the same number of X's and the same number of Y's. If this list differs for some reason, if you have more X's than Y's or more Y's than X's, you're going to get a dimension mismatch error. Basically, your calculator is going to complain because as it's reading through the X's and Y's, it reads an X and needs a Y, or it has a Y and it needs the X that goes with it. So the number of items have to be equal here. So at this point, we've completed entering our data and we're ready to move on to our next step. So now that we have our data entered, the next thing that we would like to do is to be able to display our data as a scatter plot. There's two places where I can add information that I would like displayed in a graph. I can enter equations by pressing Y equals, and I can enter stats plots that I would like to create by hitting stat plot right here. I'm going to go ahead and press second and quit to leave my editor. And I'm going to activate one of the statistical plots. So because it's in blue here, I'm going to press second and then stat plot. And you'll notice that all of my plots are currently turned off. I'm going to enter plot 1 and turn it on. So with my cursor here, and you can see I can go up or down to different stats plots. With it here at 1, I'm going to press enter, and I will press enter again now that my cursor is on, and I've indicated that this stat plot is now turned on. If I go down, you can see there's several different stat plots we can use. Right now, the first choice is a scatter plot, and that's what we want. If you recall, when we edited our data, we entered our X values in list 1 and our Y values in list 2, so I don't need to change these. And if I wish I could pick a different symbol for the graph, but I kind of like these boxes because they're easy to see and fairly large. So now that the stats plot is turned on, what I almost always do is I will zoom to make this data fit the window perfectly. It's possible that I can hit graph and not see anything because the data is out of the field of view. By default, these calculators start with there's a y-axis and an x-axis, and they just run from -10 to 10 along x, and they go from -10 to +10, I think, for y. So in order to show all the data on my stat plot, I'm going to press zoom, and the option that I want is stored down it's at number 9, and you can say it's zoom stat. So this will zoom and make all the stat data fit in the window. So as soon as I press enter, you can see here's all the data points that we just entered. And these correspond exactly to the values that we just entered on the previous slide. So that pretty much is it. We've now got our data entered, and it's now viewable as a statistics plot on our calculator. The next thing that I'm going to do is find the least squares regression line, or the line of best fit. So there is as I look at this data, it's fairly convincing that a linear relationship exists here. As the x values get larger, it appears that the y values get larger. So I'm going to find the line that fits this data best, and we've discussed what the least square regression line is, and we've also discussed why we call it that. In order to calculate the least squared regression line for this data set, what I'm going to do is press stats, and I'm going to go over to calc for calculate. So stats, and then over for calc. Once I'm here, I'm going to go down to option number 4, which is linear regression. So I'll just go down, down, down. Now that I'm sitting here, I'll just press enter. Now on your calculators, it's going to verify where your x's are coming from, where your y's are coming from, and a couple other settings. You might want to make sure that it shows that your x's are coming from list 1 and your y's are coming from list 2. And then you'll hit the down arrow several times until you're on top of the word calculate. For this calculator, I'm just going to press enter. And it does a great job of giving me the least square regression line. You can see that the equation of the line that best fits this data, and I guess I'll round it to 2 decimal places, is y equals 0.13x. So you can see a is the coefficient of x. So a is my slope. Y equals 0.13x plus 1.66. So if I'm rounding to 2 decimal places, you notice this is a 5. The next value over is a 9, so I'm rounding up. So y equals 1.3x plus 1.66. That's the least squares regression line. Now that we have our least square regression line, what we're going to do next is we are going to display that least square regression line. Again, the way that we enter things we want to see on a graph is either stat plot or y equals. I'm going to press y equals, and right here I'm going to give the calculator the equation of my line of best fit. Now I could do this one of 2 ways. I could write down all these values or the decimal approximations and enter it manually, but what I prefer to do is just to read the least square regression line because it's automatically stored in my calculator. I can access that by hitting the button vars, short for variables. I'm going to go down to statistical variables, so number 5, so I'll go down, 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 down. I can press enter now, or I can just press the 5. It's stored as an equation, so I'll go over, and you can see it's the regression equation. This will always be the last regression equation performed. So since I just performed a regression on the data set, this is the one that I want. So I'm just going to press enter here, and it automatically types it all in. You can see this is the 0.13x and then the plus 1.66. It's putting all the values that it has there, so it's not throwing any of these decimals away. At this point, if I choose to press graph again, it will show me my data and my least square regression line at the same time. So at this point, we've discussed how do you enter data into your calculator, how do you display that data as a scatter plot, how do you find the least square regression line, how do you display the least square regression line with the data. And what I want to do now is talk about how you can read information from the graph about the least square regression line and the data when you're looking at it. For the next few parts, I'm going to shift to a different data set. It's a little bit better to visualize some of the things that are happening. And this is from problem, I think it's from problem 49 in our textbook, dealing with Julia and the pizza parlor. So in this problem, she went around and collected data about different pizzas in the neighborhood, how many toppings they had, and what they were charged for it. And I'm assuming these were all medium pizzas, perhaps. So that wasn't an extra variable if it was large, medium, or small. They're all the same size. And you can see the data that I have here, right? For example, a 5-topping pizza and that included the cheese. So it's 5 toppings in addition to the cheese was $16.50. I'm going to go ahead and press graph, and you can see I've already got the scatter plot set up, and I've also got the least square regression line visible so I can see everything. What I can do at this point is press the trace button, and that allows me to take a look at 2 different things. It allows me to read the X and Y from each of my data points. So as I move to the left or right with these buttons, I can go up or down the data from the way that it was entered in the table. So this particular pizza here is a 3-topping pizza that costs $12.50, and you can see that in the data table. And there's another 3-topping pizza that was actually kind of earlier on in the data set. Right here it is. This is a 3-topping pizza that costs $9. So just in terms of a review about a function, this it's clearly a scatter plot, right? But it's definitely not, the table does not represent a function, because a 3-topping pizza either refers to $9 or it refers to $12.50. So what I want, the other thing that we can do in addition to reading just our X, Y's for each of the data points is we can shift to our model that's used to predict things. So by just clicking the up or down arrow, again, this is while trace is active, I'm now reading values from the line. And if I move over, you can see my cursor is just moving along points on the line. And it's kind of difficult to get lined up exactly with a particular X value that I want, but I can do better than that. I know that this point was a 3-topping pizza that cost $9. And I can see up here there's a value, the predicted value that this pizza should cost. And up above it, there's another pizza that had 3 toppings and cost $12.50. What you can do is you can ask your calculator, for example, if a pizza had 3 toppings, tell me what the model predicts it would cost. So if I enter 3 and press enter, it jumps right to the spot on the model where X is 3, and you can see $11.81 is what the model's predicting at that point. And as long as the equation's active and I'm within the range of my data, I could do this. So I could say, oh, what about a 4-topping pizza? And you can see it jumps right to there. We're going to use that now to discuss residuals. So let's focus on this particular pizza that had 3 toppings, and let's figure out what the residual is for the $3 pizza. I'm sorry, the pizza with 3 toppings that cost $9. So I'm going to go back to where I can look at the plot. So you can see now I'm looking at plot 1. My X's were stored in list 1 and my Y's were stored in list 2. And as I move back and forth, I can go to different points, and you can see right now this is the point where X is 3 and Y was 9. So my question is, what's the residual for this particular data point from my module? And again, the residual is how far the distance is from this point down to here. And in order to calculate the residual, I just need to figure out, I know the actual is 9, and I just need to figure out what the predicted value is. So in order to calculate the predicted value, I'm going to switch back to my model, and I'm going to enter the number 3 and then enter. And you can see it jumps right here. So it's just right above it exactly. And it's saying a pizza with 3 toppings is predicted to cost $11.81 in this neighborhood, $11.81. And in order for me to calculate the residual, I'm going to take the actual value of 9 and subtract the $11.81. And when I do that, I'm going to get a negative number, and it will be the residual for this particular data point. So let me go ahead and do that. I'll just hit, I'll quit the graph, and I'll go ahead and take the actual value of 9, and I will subtract from that $11.81. And when I press enter, you can see that I have a residual of negative $2.81. So at this point, I can see this is negative 281, and that's probably the largest residual for all the data in this set. So if I wanted to create like an upper and lower band, I could add add 281 to this y-intercept and subtract 281, and I would create a band that would give me where I know that all of my data lives within that upper and lower bound. So anyways, that's pretty much the procedure for figuring out what a residual is. It's helpful to use the trace feature because especially when you're here, you can say, hey, I have a pizza that had one topping and cost $10.50, and I can see it here. Well, if I ask it, what is the number of toppings, or what would the predicted cost be for a one topping pizza? Well, my model says the price would be predicted to be $9.09. Or actually, if I'm rounding to the nearest penny, because that's an 8, I would have to round this to 9.10. And again, this would be a positive residual, so I would be taking this 1050 and subtracting the predicted value of 910. So we found a single residual. Actually, we found two residuals on the previous slide. And now I'm going to show you how you can find all of them automatically. One of the things our calculator does is every single time you perform a linear regression, in other words, whenever you hit stats and then go over to calculate and do option for a linear regression AX plus B, it generates a list of, oops, that was not the right thing. I'm supposed to hit stats, calc, and then option number 4. There we go. When we do that, it generates a list of all the residuals, and it also created an equation that we looked up in the list of variables before vars earlier on. What we can do is we can look at all of our residuals at once, and we don't have to go through our graph and figure out all of them and calculate them kind of by hand. What this looks like is I'm going to go into stats, and I'm going to edit a list. And what I propose doing is I'm going to come over here and I'm going to add all of my residuals right here in this column to list 3. Now, in order to do that, I need to move my cursor so that it is flashing on list 3, because think about this conceptually. I'm bringing in a whole bunch of numbers, and I can't store a list of numbers in one of these boxes, right? Each one of these boxes, as I move up and down, is just capable of storing a single value. So when I'm up here, though, I can grab all of the residuals and put them in this list. So this says list 3 equals. In order to grab my residuals, I'm going to press second and go to the stat button, but above it, it says list. So I'm trying to find a list, second list. And the list that I want is the list of residuals from my least regression that I did, the last regression that I did. So I'm going to press 7. It jumped to that. So it says list 3 is going to be the list of residuals. And as soon as I press enter, you can see there they all are. And we found one of these earlier, if you look. Actually, I can't remember which one it was. I think we found the one for, yeah, this one, right? We found the one for the 3 topping pizza that had an actual cost of $9. We found its projected cost, or the predicted cost, I think was $11.81, and the residual there is, I think, $2.81, and it was $2.81 below the line. So these are all of our residuals. So it's kind of powerful to know that you don't have to go through and find each of the residuals individually. You can find them all at once. They're just in that list of residuals that lives right here in the list menu. Now that we were able to find all of our residuals and we stored them in list 3, it's pretty simple for us to create a residual plot. In order to create the residual plot, instead of plotting our x's as list 1 and our y's as list 2, we're going to go ahead and pick L1 as still our x's, but our y values are going to be those stored in list 3. So in order to modify our stat plot to show the residual plot, I'm going to press second and go to my stat plot menu again. And I'm going to modify plot number 1. Before, you can see I'm reading my x's from list 1 and my y's from list 2, and that gave me a nice scatter plot of my data. I'm going to come down here and I'm going to modify my y values. Instead of list 2, we're going to read them from list 3, the list of residuals. So I'm going to clear this, And in order to access list 3, I can see on button number 3, it says L3 or list 3 right above it. So to get to that, I'm going to press the blue second button and then hit list 3. So at this point, I'm going to be reading X's from list 1 and Y's from list 3. The other thing that I like to do is to zoom this so that it fits better. So I'm going to press zoom, and then it's down here at option number 9. Zoom stat. So I can just press zoom and then the button 9 and it jumps right to it. Now, one of the things you'll notice that's different is I now have the x-axis visible, right? And the reason why is along the x-axis, y's are all 0. And if you look at it, some of the residuals are positive numbers and some are negative numbers. So that's what I'm seeing here. And if I look at the residuals, I can see, a positive, 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 positive. These three values are negative residuals. And it's telling me how far, remember what a residual is, it's telling me how far a particular data point is from the predicted value. If a point was exactly on this line, then there would be no distance between its predicted value and its actual value, and it would have a residual of 0. All of these have a residual of something. And one of the things that I want to point out is what's the sum of all of these? So if I was to take each one of these residual values and add them up, what would they sum to? What would their sum be? Well, remember, all of these are stored in list number 3, and I have a convenient way of figuring out what the sum of all those values are. I'm going to go to my stat menu, and I'm going to perform one variable statistics on list 3. So I've hit stats, calc, one variable stats, and I'm just going to tell it on which list. I'm going to press second, list 3. So this will perform a one variable statistical analysis on list 3. And the one value I'm looking right here, this is the sum of all of those values, right? The sum of them is 0. So if I add all of my residuals up, I end up getting absolutely nothing. And when you think about it, it kind of makes sense because we're saying that this is the line of best fit. And what we're doing here is we're trying to cancel out the sum of the squared errors. So yeah, I guess it would make sense that all of these errors together would be no error at all. Now that doesn't really tell me that it's a particularly good line of fit. It doesn't tell me a lot about it, but it is interesting to note that the sum of the residuals ends up being nothing. And finally, there's one value that we haven't discussed yet, and we haven't actually seen it displayed on our calculator, and that's R, or the correlation coefficient. Remember, R attempts to give us a unit list description of how tight an association we have, how close our values are to being all on the same line. And values of R do range from -1 to +1. If we have an R of -1, that means we have perfect correlation. All the points are on the same line and it has a negative slope. And if we have R equal to 1, that means all of our points are on the same line and we have a positive slope. So the slope doesn't mean that it's either -1 or +1. It just means it's a positive slope or a negative slope. So as long as it's a positive slope, it fits, and the points have to live on the line. So let's go ahead and figure out what the correlation coefficient is for the pizza data that we've been looking at. I'm going to turn the calculator back on, and you can see I'm still looking at the residual plot from the previous problem. And if I hit go in and I look at my data, you can still see that I've got list 1, list 2, and list 3. I am going to go ahead and hit second calc, and I'm going to do the linear regression again, option 4. And when I do it, you can see I get the exact same line of best fit. And actually, we didn't do this for this one, but you can see it's y equals 1.36x and then plus 7.74. Now, what I don't see on this screen is r, and I don't see r squared. But I can add them to the screen. And in order to add them, it's just a matter of activating a command that's stored in the catalog. And then all of a sudden, my correlation coefficient r and R squared, the variance will show up. So in order to get to those, the catalog is right here on button 0, and it's the blue option above it. So I'm going to press second and go to catalog, and I'm looking for the command diagnostics. Diagnostics, if I go down, I have to get all the way to the letter D's. There is a shortcut to jump to the D's, but rather than show you that, I'm just going to keep pushing until I see the D's. If this is a calculator you own, you don't have to do it very often, but it's nice to say, oh, I'm looking for D's. So here we are, and you can see the two commands are diagnostics off and diagnostics on. We want to activate our diagnostics, so I'm going to press enter to grab the command, and then I have to press enter again to execute it. So you can see diagnostics on, done. It's done that. Now that diagnostics is turned on, if I perform my regression again by hitting stats, going to calculate, and then coming down to option 4 linear regression, you can see now I can see both R and R squared. So here my correlation coefficient is 0.86. I can tell just from that value that my relationship had a positive slope, and my data points were relatively close to the line, right? It's a pretty not the tightest linear relationship, but they're definitely closer to the line than perhaps they could be for some other associations. So it's a fairly strong association. And then also we talked about this R squared and what it means. If this is a fairly new statistic for us, so we'll be talking about R squared more later as we move on. But for now, know that you can get the correlation coefficient R by just making sure diagnostics is turned on your calculator.